नमस्कार। आज की वीडियो में मैं आपको बताने जा रहा हूँ डिफरेंस बिटवीन स्पॉन्टेनियस एमिशन एंड स्टिमुलेटेड एमिशन। देखिए, हमारा जो लेजर प्रोसेस है वो स्टिमुलेटेड एमिशन पे बेस्ड है, बट वी कैन नॉट अवॉइड स्पॉन्टेनियस एमिशन। ये दोनों प्रोसेस किसी भी लेजर के अंदर होती रहती है। अब इनमें डिफरेंस क्या है, देखिए। स्पॉन्टेनियस एमिशन बड़ा सिंपल है। यू कैन सी हियर व्हाट इज द डिफरेंस बिटवीन स्पॉन्टेनियस एमिशन एंड स्टिमुलेटेड एमिशन। सी, here we are having two energy levels, E1 and E2. E1 is lower energy state and the E2 is upper energy state. Here in energy state E1, N1 is the number of atoms and here N2 is the number of atoms. So in spontaneous emission, initially atoms or the ions is in excited state or the upper energy state. So in any upper energy state, the atom or the ion can stay only for a very short period of time, that is 10 raised to the power minus 8 second. After this time period, it will make a transition to the lower energy state by emitting some radiation. But that radiations will be incoherent radiation. Okay. That will not be a coherent radiations. So this process is called spontaneous emission. Then stimulated emission, what happens basically? This is incident photon. This one is the incident photon of energy h nu. Obviously, it is equals to E2 minus E1. And the atom is already in the excited state, E2. Okay. So after 10 to the power minus 8 second, it will have to make a transition to the lower energy state. But before that time of period, this incident photon will stimulate this atom, will trigger this atom, and will compel this atom to make a transition to the lower energy state by emitting an additional photon of exactly same energy h nu as of the incident photon. So in that way, two photons will be emitted here. You can see one is the incident photon, it is going state, and one photon, an additional photon is emitted here because of this atom. It is making a transition from E2 to E1. So this incident photon trigger stimulates this atom and make a transition to the lower energy state by emitting an additional photon of the same energy as of the incident photon. In that way, we are getting here two photons of exactly same energy, and these two photons maintain a constant phase relationship. Now, what will happen in the next step? These two photons will interact, will stimulate two atoms in the excited state E2. Now these two atoms will come down. So two more photons will be produced. In that way, four photons will be produced here, emitted here. So in that way, chain reaction will happen. The multiplication of photons will take place due to stimulated emission. Now, how we can differentiate in some points? It's very simple. See, okay. The one is, for example, we can represent in that way. The atom in the excited state is denoted by this A star. So when it will come to the lower energy state, it will be equals to A plus H nu. A is the atom in the ground state, or A star is the atom in the excited state. Now here, what is happening? Already atom is here in the excited state. Now this incident photon H nu, when it will come down, what will happen? A plus H nu plus H nu. These two photons will be emitted here. The second difference is that these two photons, or the emitted photons travel in different direction, in different direction. But here, in case of stimulated emission, all the emitted, all the emitted photons travel in a single direction. Second difference. Now, the third one is very important again. No phase constant. No phase constant. Because when this atom will come here in the low energy state, it will emit some radiation, some photon. Now the next photon will be emitted at different time because of different phase. So the photon which are emitted here in spontaneous emission, they do not maintain a constant phase relationship. But here in stimulated emission, okay, the emitted photons, the emitted photons have a constant phase relationship. Okay. And because of this, here we have incoherent light. Incoherent light. But here, in case of stimulated emission, because all the emitted photons, they maintain a constant phase relationship. So here we are getting coherent light. Here we are getting coherent light. So thank you for watching this video.